So now we are starting the second part of today's class. So in this one, we are focusing on this particular question. This is from November 2020, variant 53. So November 2020, variant 53, and this is question number 6. The question says 3 coins ABC are each thrown once. Coin A and B are each biased so that the probability of obtaining a head is 2/3. So let me write over here A, B, C. Let me write over here head. And in green, I'm writing tails. So for A, the probability of obtaining a head is 2/3. Probability of obtaining a head for B is also 2/3. Tails would be 1/3, 1/3. And for C, the probability of obtaining a head is 4/5. So this is 4/5 and this is 1/5. Now, first, I'll focus on what needs to be done, and then I'll show you the solution. Part A, show that the probability of obtaining exactly 2 heads in one tail is 4/9. That is the first part. The random variable X is the number of heads obtained when 3 coins are thrown. Draw up a probability distribution table for X. So 3 marks for this, 3 marks for this. Altogether, if I draw the whole table, I'll get all the 6 marks. Now, let me just first focus on the table. I won't do the calculation. I'm just writing it down. So if I draw up a table, this table will contain what? This table will contain X and the corresponding probability X is equals to X. If I'm throwing 3 coins, I'll get 0 head, 1 head, 2 head, and 3 head. Now, the easiest one, the 2 easiest ones to calculate are 3 heads and 0 head. X is the number of heads obtained. So if I want to calculate probability of 0 head, I've technically skipped part 1 for right now. So 0 head means all 3 tails. That means 1/3, 1/3, 1/5. So that is 1/3 into 1/3 into 1/5. 9 into 5 is 45. That's 1/45. If I talk about probability of 3 heads, that means all 3 heads, that should be what? 2/3, 2/3, 4/5. 2/3 into 2/3 into 4/5. 2 2s are 4. 4 into 4 is 16. 16/45. These are the easiest 2. Now, what I'll do is that I'll calculate this one, 2 heads, because this is being asked in part A. And this I'll obtain from subtraction because it's a DRV. So 2 heads, if I focus on this, now let's look at this color coding. So I'll do head, head, and tail. That is one option. So first, let me write 1, 2, 3. That is the first option. The second option, that is head, tail, head. So this is head, tail, head. And the third option in orange, that is tail, and then head, and then head. That's a tail and a head and a head. So now let me write it down. The first one is 2/3 and 2/3 and 1/5. The pink one is 2/3 and 1/3 and 4/5. And the last one is 1/3 and 2/3 and 4/5. So this is 2 into 2. This is 4/45. This is 8/45. This is also 8/45. Either this or this or this. How much is that? 16 plus 2, 20/45. So this comes out to be 20/45. This is 16/45. This is 1/45. How much is that? 37. So how much is left? 8. So this answer from subtraction comes out to be 8/45. So which one is 13? Let me just double check. This is 20 plus 16, 36. 36 plus 1 is 37. 45 minus 37 is 8. Sahi hai? Let me double check. So that is the working I've done before. This is the one. Now look at my different style of working. Over here, I have noted it down like this. 0 head, 3 tails, 1 head, 2 tail, 2 tail, 1 head. Technically, it's the same thing, but I'm just showing you the way in which I've written. This is a different way of writing it. And over here, I've done it differently. It's the same answer. Okay? So now this thing is done. let me move ahead and let me just look at the thumbnail. And the next one, that's right over here. Okay, another geometric probability distribution. I think this is pretty basic. This is basic too. We just focus on this. Okay, now let's look at this. The random variable x takes the value 1, 2, 3, 4 only. The probability that x takes the value x is given by this formula where k is a constant. Draw up the probability distribution table for x. Let me just check one thing. That is the recording and everything. Yeah, it's all right. So now over here, we put 1 over here and we get the value, the probability in terms of k. Plug in 2, plug in 3, plug in 4. So 1, 2, 3, 4 only. That means all these 4 probabilities should add up to 1. So the value of k comes out to be 1 over 20. Then expectation of x, as usual, x into the corresponding probability and add it up. And expectation of x squared, make a column for x squared, 1, 4, 9, 16, and work out the same thing. Or if you don't want to make a column, you can still write over here, instead of 1, 1 square, instead of 2, 2 square, 3, 3 square, 4, 4 square, and then apply the formula, you will find this answer. So that was pretty basic. Next one, let's have a look at this. Another table question. The question says there are 400 students at a school in a certain country. Each student was asked whether they preferred swimming, cycling, running, and the results are given in the following table. So now this is like a matrix. This is 2 by 3 matrix. So 104, this is for swimming, this is cycling, this is running. Over here, the total is not given. If you compare it with the first part of the video, the total is not given. Now it says a student is chosen at random. Find the probability student prefers swimming. So 104 plus 31, these are the swimmers. That is 135 out of a total of 400. That is the first answer. Determine whether the events, the student is male and the student prefers swimming. So this is student prefers swimming. Student is male, that is 31 plus 57 plus 92, whatever that is 180 over 400. Are these two events independent? What else do I need? I need the intersection. That is 31 over 400. If this is equal to multiplication product of the individual probabilities, we will say it's independent. Otherwise, it's not independent. So this thing is also done. Let's move on and let's look at this question. And yes, this question, let me just add a page. I'll share this page for you, and I want you people to try it out first. Let me pause the recording. So now let's look at the solution of this question. Before that, let's go over it exactly what they're asking. Let me start underlining. Sharma knows that she has 3 tins of carrots, 2 tins of peas, 2 tins of sweet corn in her cupboard. All the tins are same shape and size. That means she cannot distinguish between them. But the labels have all been removed, so Sharma does not know what each tin or can contains. Sharma wants carrots for her meal, and she starts opening the tins one at a time, chosen randomly, until she opens a can of carrots, a tin of carrots. Now let me pause over here. You see the word until over here. Will this make it geometric? Yes or no? Yes. No. The reason is the probability is not fixed. So therefore, it's not geometric distribution. That condition has to be fulfilled. The probability is not fixed because this is without replacement. Now it says the random variable x. Yes, it's a DRV question, but DRV does not necessarily have to be binomial or geometric. It could be something else. Show that probability x is equals to 3 is 6 over 35. That means the third tin that she opens, that is of carrots. So now, first of all, the thing that you need to distinguish is that carrots How many are there? 3. And non-carats, anything else, that is how much? 5. 4, sorry, this 2 and 2, that is 4. So now, first of all, if we talk about 3, the denominator should be 7, the denominator should be 6, the denominator should be 5. Do you agree? The first 2 should be something else. It could be anything else. So it could be any one of the 4, any one of the 3, and the last one has to be 3. I'll show you the full solution. But before that, start thinking. 7, 6, 5, the denominator will decrease. Any one of the 4, any one of the 3, any one of this 3. So let's start the cancellation. 3 ones are, 3 twos are, 2 ones are, 2 twos are, and 2 into 3 is 6. 5 into 7 is 35. So therefore, 6 over 35, that is the answer. Then now the next part. Draw up a probability distribution table for X. How many cans of carrots does she have? 3. That means either it will take 0 attempt or 1 attempt or 2 attempt, whatever the possibilities are. Let's think about that. We want a can to be opened. So 0 possibility is not there. Maybe she opens at the first attempt. So that is simply 3 over 7. Opens at the second attempt. So just focus on the denominator first. 1 attempt, 7. 2 attempts, 7, 6. 3 attempts, 7, 6, 5. That is what I just did. 4 attempts, 7, 6, 5, 4. And since there are 4 cans of anything else, so the possibility will go till the last attempt, the 5th attempt. That is 7, 6, 5, 4, 3. I have used red color for carrots. I have used purple color for any other. So therefore, look at the working. The working is this. That is, that first of all, if I write probability X is equals to 1, this is 3 over 7. That is basic. Probability X is equals to anything else and then caret. Anything, and then caret. Probability X is equals to 4. 3 of anything, each reducing by 1, and then caret. X is equals to 5. You have used up all the other cans. So naturally, you will get success at the end. That is the working over here. So it's not binomial. It's not geometric. This is without replacement. You have to write it out in terms of probability. Okay? Yes.
मेरा क्वेश्चन है कि अगर हमसे पूछते हैं कि प्रोबेबिलिटी ऑफ फाइंडिंग कि कैन इज ओपन अभी खोलने के लिए जो एक्स है ये कैरेट का कैन है अगर सिर्फ ओपन करने की प्रोबेबिलिटी पूछते हैं उसमें तो सारी प्रोबेबिलिटी कैलकुलेट करके उनको ऐड अप कर देते हैं क्या हम उस वक्त जीरो की प्रोबेबिलिटी निकाल के नॉट ओपन निकाल के टोटल्स माइनस कर सकते हैं?
That's a good question. You mean to say that if you are talking about probability of just opening, so that is 1 minus the probability of not opening, this part is correct. But over here, that's not the question. The question is different. So what you have asked, of course, that can be done that way. Okay, Ji. Then it's expectation and variance, all these things. Let's choose another question, something like this. Let's look at this one. Another geometric question. An ordinary fair die is thrown repeatedly until a 5 is obtained. Now the probabilities are fixed over here. The number of throws taken is denoted by random variable x, geometric probability distribution, work in fractions because we are dealing with fractions. P is 1 over 6, expectation x is the reciprocal. Find the probability a 5 is first obtained after the 3rd, but before the 8th throw. So over here, I have written each one separately and added it. So that is 3rd, 4th, 5th, 6th. For 3rd throw, after the 3rd, that means 4th. So it's 4th, 5th, 6th, 7th. Neither is 3 included, nor is 8 included. So that's 4th, 5th, 6th, 7th. Just calculate each probability and add it up. Find the probability 5 is first obtained in fewer than 10 throws. The 2 rules. Fewer than 10 is lesser than or equal to 9. So that's 1 minus probability of failure raised to power of 9. Let's look at some other question and then we'll go to 2023 if nothing special is left. Now, this is the question that I was talking about. That tomorrow question. Okay. So this is May, June 2021. I just don't want to digress from this thing that is a probability and distribution. So this is the question in which I have used this dollar thing, and then it's about probability. So I'll share that link and you can then watch this particular one. Let me focus on this thing. Now, this is 2023. Let's look at this question. Ellie has four fair, So four fair, four-sided dice with labels 1, 2, 3, 4. He throws all the 4 dice at the same time. The random variable X denotes the number of 2s obtained. Show that probability X is equals to 3 is 3 over 64. Now, probability of getting a 2 is 1 out of 4. Not getting a 2 is 3 out of 4. You are throwing 4 dice. So it says X is equals to 3 means 3 2s and 1 is not a 2. So that is 2, that is 2, that is 2, that is not a 2. And this thing can be arranged in 4 factorial divided by 3 factorial ways. Now, that was my first gut feeling of writing it down, because I have just solved that Sharma question, the 10 of carrots. But if I think more deeply, this is binomial, because the probability is fixed. The number of trials is mentioned. We are talking about throwing 4 dice. The success is fixed. Getting a 2, 1 over 4, not getting a 2, 3 over 4. So alternatively, I can use binomial distribution. Then it says copy, it does not say copy, complete the following probability distribution table for X. So probability X is equals to 1, again binomial. Probability X is equals to 2, again binomial. Or if you have to complete it, this is given, this is given, this is given, this is given. This can also be found by subtraction. So not a big deal. Find expectation of X and then the normal approximation, that is straightforward. The second one, again, a simple question. The random variable X takes the value -2, +2, and 3, and it is given that probability X is equals to X is following this formula. Draw up the probability distribution table for X, giving the probabilities as numerical fractions. First, you plug in the values, you get the answers in terms of K. Either you can write it in terms of K and then evaluate K, or you can add it all up, first evaluate K, and then write the answer as fractions. Eventually, you have to do that. So K comes out to be 1 over 14. This is 3K. This is 3 over 14, 3 over 14, 8 over 14. Find expectation and variance. That is straightforward thing. Now, this looks like a difficult question to me. Let me just give you the images first. I would like you to try it out. So now let's look at the solution of this question. The question says a sports event is taking place for 4 days, beginning on Sunday. Sunday, Monday, Tuesday, Wednesday. The probability that it will rain on Sunday is 0.4. So this is fixed. On any subsequent day, the probability it will rain is 0.7 if it rained on the previous day, and 0.2 if it did not rain on the previous day. So now we are starting with the information given is the probability that it will rain on Sunday is 0.4. So Sunday rain 0.4, Sunday dry 0.6. R for rain, D for dry. And then if it's the next day, the probability it will rain is 0.7 if it rained on the previous day. So rain after rain is 0.7 and rain after dry is 0.2. So this is very similar to the question that was given with the tree diagram, the April 1st or the 2nd, something like that. Find the probability it does not rain on any one of the 4 days of the event. So first of all, Sunday, no rain. Sunday rain is 0.4, no rain is 0.6. Now, based upon 0.6, we want Monday to be dry. So if Sunday is dry and then a dry, that is this 0.8, that's over here. So basically, I list them out and then I pick and choose. And then based upon dry, you want it to be dry and dry. So based upon dry will be dry, that would be 0.8, 0.8. So this is 0.8, 0.8, 0.8 into 0.6. Now 6 into 8 into 8 into 8, I have taken care of all the zeros in the denominator, and that is the answer. Of course, you can use a calculator. The next one. Find the probability that the first day on which it rains during the event is Tuesday. So this is like not exactly the same, something like geometric. So this is dry, Sunday is dry, that is 0.6. Monday is dry, based upon a dry day is 0.8. And Tuesday is rain, based upon a dry day is 0.2. So Tuesday is rain, based upon a dry day is 0.2. And that's it. You just want to work till Tuesday. You're not interested in Wednesday. 0.6, 0.8, 0.2, that comes out to be 0.096. The next page. The same information is again written over here for simplicity so that I don't have to flip the pages all the time. Find the probability it rains on exactly one of the 4 days of the event. Now, first of all, I have listed the possibilities. Sunday, Monday, Tuesday, Wednesday. First day rain, second day rain, third day rain, fourth day rain. Once I have listed this, now I can work it out. Sunday rain is 0.4. Based upon a rainy day, the next day is dry, is 0.3. So let me just double check. Sorry, it's over here. Based upon a rainy day, the probability that it's dry, it's 0.3. Based upon a dry day, the probability it's dry is 0.8. So this is 0.4, 0.3, 0.8, 0.8. Similarly, you just fill out the rest. These are all the different answers in the fractional forms. I added it all up, and the answer in decimals is also exact. So it's not necessary that you work in fractions. You can work in decimals also. So now this thing is done. And we are over here. Let me look at this. Okay, maybe that was a mistake. I'm not sure. So let's move on. This is again a geometric. Let me choose something different. This is, okay, just go over it. The random variable x takes the value 1, 2, 3, 4. It is given that probability x is equals to x follows this formula when k and a are constants. Then it says, given that probability x is equals to 4 is 3 times probability x is equals to 2. So we plug in x as 4 in this equation. Probability x is equals to 4 simplifies to this. Probability x is equals to 2 simplifies to this. This probability on the left is 3 times this probability. The k cancel out. We find the value of a. That was simple basic algebra. Probability x is equals to 1. Now that a has been found, we replace a. Now probability x is equals to 1, 2, 3, and 4. Again, we get the 4 probabilities in terms of k. We add it all up. We equate it to 1 because it's a DRV. Sum of probabilities is 1. We get the value of k, which is 1 over 50. I think the rest of the thing is easy. That is the PDF. That is the expectation and variance. Let's move on. So now, let's see. Now, this is again a good question. Let me add a page, share it with you, and then you can try it out. So now let's look at the solution. The question says, Jasmine throws 2 ordinary fair 6-sided dice at the same time and notes the numbers on the uppermost faces. The events A and B are defined as follows. Event A, the sum of the 2 numbers is less than 6. So now what I have done over here is that I have made a full table with all the 36 possibilities, and the blue circle represents that the sum of the 2 numbers is less than 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, that is 10 out of 36. That's the first thing. The second thing, the difference between the 2 numbers is at most 2, And if it says difference, naturally it means a positive difference. At most 2, it could be 2, it could be 1, it could be 0. 1 and 1, the difference is 0. 2 and 1, the difference is 1. 1 and 2, the difference is also 1. I have again filled up a whole table. And how many possibilities do I get? I get 24 possibilities. Those are denoted by green color. 2 things are done. Determine whether or not the events are independent for 4 marks. So let's say 1 mark for this whole working, 1 mark for this whole working, 1 mark for figuring out what the common ones are, and then 1 mark for relating them in that equation. So now these pink stars, they are the one that is fulfilling both the criteria. The sum of the 2 numbers is less than 6. At the same time, the difference between the 2 numbers is at most 6. Now over here, what I observe is that this pink one, I think is for the next one. My bad. This pink one is for the next one. This purple one over here. So now out of these 10, how many of them would have this thing? The difference is at most 2. So out of these 10, 1, 2, 3, 4, 5, 6, and then 7 and 8. So basically this 3, and these 3. Now just focus on this. These 3, and these 3. So there are 8 of them, which are the common ones. That is 8 over 36. So therefore, 8 over 36, does it equal to the individual, the blue and the green probability multiplying together? The answer is no. Therefore, they are not statistically independent. That's it. So that is 4 marks for this. Okay. Now what's the story of this pink one? Let's see. It says find probability B/A complement. Now the rule is, let me write it over here, or I've added a page. Let me write it over here first. The rule is probability of A/B. It means probability of A occurring given B has already occurred. That means this B over here, this is the condition. Now, how do we officially write it? In simple questions, we don't need this set notation as such. Probability of A intersection B divided by probability of B. The condition goes down in the denominator and the common thing with the scenario goes up. That is the official rule. Over here, they have written probability of B/A complement. By the same token, how will I write it? Probability of B/A complement. What is the condition? A complement. So I'll write probability of A complement at the bottom and probability of B intersecting with A complement, that will go at the top. Now, in this context, let's look at the solution. First of all, I have written this thing over here. Probability of B intersection A complement divided by probability of B. The next thing, that is A is what? Sum is, A is sum of the 2 numbers is less than 6. So what is A complement? It's greater than or equal to 6. That means it is at least 6. So that is all these possibilities. That's right over here. If this is 10 over 36, this is 24 over 36. That is the first thing. 36 minus 10, that is 26. 26 over 36. Thank you. So this probability of this condition is 26 over 36. That's the first thing. That is this event. Wait a minute. They are asking for B/A complement. So this A complement is this thing. This is, let me write it over here. Probability of A complement is 26 over 36. That's the first thing. Now, is there any common thing between B and A complement? What is B? The sum of the 2 numbers is at most 2. At the same time, A complement is all these 36 or 26 possibilities, all these ones. So now look at these common ones. So from these green ones, these are the common ones that goes over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that comes out to be 16 over 36. So basically the answer is 16 over 36 divided by 26 over 36. I think this was mistakenly written as B. This is basically A complement. So let me just correct it. This is A complement over here. And then we divide and we get the answer as 16 over 26. Out of 26 possibilities, we can also do it directly without using the formula. How can we do it directly without using the formula? There were 26 of these possibilities, correct? Out of these 26, how many of them are those in which the difference is at most 2? So out of these 26, just focus over here. So now these green ones, they start from here. So let's say this first row, there is nothing in common. Second row, out of these 3, are there anything in common? Yes, this one of them. Then go row by row. Out of these 2, is there anything in common? Out of these 4, is there anything in common? Yes, 1, 2, 3. Out of these 5, is there anything in common? Yes, 1, 2, 3, 4, 5. Out of these 6, is there anything in common? Yes, 1, 2, 3, 4. Out of these 6, is there anything in common? Yes, the last 3. So out of 26, 16 are common. So therefore, the answer is 16 over 26. So that completes this lecture on probability and DRB.